Let's go to continue with the second part of chapter 9. In this case we go to the population mean case number 2, when sigma is unknown. That means we don't know the standard deviation of the population, but we will know the standard deviation of the sample. So in this case, if the population standard deviation sigma is unknown, we have to use the sample standard deviation S. So instead of using now the Z distribution, the normal distribution, we have to use the T distribution, as you can see here. Now the assumptions are going to be pretty much the same. The formula looks very similar to the previous one, with two differences. We still have the X bar, we don't have the Z, but we have the T with the n-1 degrees of freedom. N is how many observations you have. And then instead of having sigma, you have S over square root of n. Now the T distribution is a family of distributions and depends on the degrees of freedom. The degrees of freedom is the number of observations that are free to vary after sample mean has been calculated. And the degrees of freedom will be n-1. That means how many observations you have minus 1. And this is how the T distribution looks like compared to the normal distribution. So let's go to see an example. Calculate the T value for a 95% confidence interval for 25 observations. Now in this case, if we have 25 observations, we have 24 degrees of freedom. So we have to go to 95% and 24. And this is the T table that I sent you today. So we have to go to 95% and then we go down to 24. And as you go through this table, you're going to be able to see the value for the T. So 24, and then you go to 95%, and this is 2.064. One more time, you have to go to 95%. So the confidence interval for the T will be the 80, the 90, the 95, 98 and 99. I have to give you one of them. So you go to 95 and then you go down to 24 degrees of freedom and it's 2.064. And this is exactly the same value here. Let's go to see a second example. 98 with 10 observations, 98%. So that means 9 degrees of freedom, 10 minus 1. So let's go to 98 and 9. So what we have to do is that we have to go to 98%, the fourth column, and we go to 9 degrees of freedom. So here we are, 9, and this is the value, 2.821. And this is exactly the same value. Example number 1. In this case we have a sample of 25, the sample mean is 50, and the standard deviation of the sample S is 8. So as you can see, this is going to be the T value. First of all, the T value is 2.064, the same as before. We have 24 degrees of freedom, and this is going to be the confidence interval. Let's go to use for the same problem the graphing calculator. So in this case, this is the graphing calculator. We go to Stat, we go to Tests, and we go to now to number 8. Before we went to number 7, now we go to number 8, T interval. Click Enter. Highlight Stats, X bar. The X bar for this problem is 50. Then we go down to the standard deviation of the sample, which is 8, and then the N is 25. Confidence level is 95%, so we keep it as 0.95, and then we click Calculate. It takes a couple of more seconds to calculate the confidence interval. So here it is, 46.698 to 53.302. Exactly the same result that I have when I use the formula manually. Next, we have the case number 3 that I will show you the formula. This is the confidence interval for a population proportion, but we can only use the graphing calculator even though I have the formula here. This is the PS, the proportion of the sample. Always we have a Z, and this is the formula. But I have the steps for the graphing calculator where you have to go, and I will show you right now. It's very similar based on what we did before for the Z and the T. So we have exactly the same steps. So let's go to see this example. We have a sample of 100 people that shows that 25% are left-handed. So we have to create a 95% confidence interval. And again I use the formula, but let me go through them graphing calculator. So what we have to do, we have to go to Stat, we have to go to Tests, again same steps, and now we go to letter A. It says 1 proportion Z interval. Click Enter. Now X is going to be the number of successes, in this case 25, and then the N is the sample size. We have a sample of 100. And then the confidence level. So for the proportion, what you need is that you need the X, which is the number of successes, you need the N, the sample size, and then the appropriate confidence level, which is 0.95 in this case, which is the most common. And then you click Calculate. And again, as you can see, 0.165 to 0.335. That means from 16.5% to 33.49%. And as you see, we did both steps manually and by using the graphing calculator. And this is the explanation. We are 95% confident that the true percent of left-handers in the population is between 16.5% to 33.5 or 49%.